Hello class, we're on lesson number 7, chapter 11, and we're going to go into dividing fractions. Now, we can sit here and read all of this. I think that they take a very roundabout approach to teaching us how to divide fractions. And you can sit here and look at some of the complexities here. We can read about Thomas Edison and how they made a frame or several frames of a man sneezing, and the frames were taken at a rate of 16 per second, so each frame lasted 1/16 of a second, and the 12 frames shown ran for only, well, 12 times 1/16, which would give you 12/16, or let's say 3/4 of a second. Well, how many frames would be required to photograph a sneeze lasting 2 and 1/4 seconds? Now, you could do that by dividing. So they take us through a whole complexity of dividing here, and I don't want to go too deep into this because really dividing fractions is so much easier. You can go ahead and read this and you can see it. I don't necessarily want to teach it right now because I really want to do what you call cutting through the chase, okay? And I really want to go all the way down. And I want you to understand the first element, okay? You have dividing fractions. And I want you to understand that when you write fractions, you can write them two different ways. You can write them as a fraction, you can write them as a quotient. Okay? So let's just take A over B, and I want to divide A over B by C over D. Okay? Now what we have here, we can write it that way, and we can also write this as A over B divided by C over D, right? Now the reason I'm doing this is because it's really a lot simpler than all of these fractions that we're looking at on these two pages here, and we can get a little confused understanding how simple it is. So we can take that really long way, and I could lose you, and I don't want to lose you with this because it really is too simple. I typically try to show you the hard way so that you understand the elements and the components. In this case, I know that fractions present a particular issue with some of us. We just don't feel comfortable with fractions, and I want you to understand that I think that dividing fractions, though as crazy as it sounds, it's really one of the simplest things, because all you need to do is take the two fractions, right? A over B divided by, and I'm using the quotient over here, C over D, and all you need to do is reciprocate here, the second one. So you have A over B, and when I say reciprocate, I'm going to be able to multiply the reciprocal, which is D over C. Okay, so when you have a fraction, the reciprocal is you flip the numerator and the denominator. So that's really all you need to do. Okay, is A times D over B times C. So I would have simply multiplied A times D on the top and placed that on the top, and B times C and place that on the bottom. It's really that simple. Now if we look at the example that we have over here, we have A over B, and we can say that A over B, if we're going to try to create excuse me, a common denominator, we would have to then multiply A over B by BD, which would be the two denominators, right? And again, C over D by B over D. Now we're just simply, again, multiplying this all by 1, right? You see? That's all we're really doing. And it's part of the reason why I didn't take this route. It is really the long way, but you can see that I can simply express this now as A over B, and and actually I can just bring the b and the d in here, right? Because I'm multiplying this, and this is all over c and the b and the d, right? Times, this is all being multiplied. And then what do? I just eliminate the d, eliminate the b, and what do I end up with? Well, I shouldn't write that equal there. It really is the whole fraction. So let's write it here. And what do I end up with? A times d over c times b, or b times c. Let's write it that way. So they're in order, which is the same thing we did here, okay? Now, I just want you to understand that this really is the shortcut, but you will get these, obviously these fractions that are going to be much more complicated. But if you remember the principle that when you're dividing fractions, you're simply taking the reciprocal and multiplying, and we really do that even with numbers, right? Let's take 10 divided by 2, right? Well, if we reciprocate 2, really it's 2, this is 10 over 1 divided by 2 over 1, right? And if we followed this, that would mean, let me just go upward where I have some room here, I would simply have 10 over 1, right, times 1 over 2, the reciprocal. Okay, and we're kind of right back to this, 10 over 2. So you could see that all you have to do is reciprocate the denominator and then multiply it to the numerator, or multiply it with the numerator. So because of the result, and let's just go ahead, actually that's just at the very bottom of page 539. This says that dividing by the fraction CD is equivalent to multiplying by the fraction DC. The fractions CD and DC are called reciprocals of each other because their product is 1. Now, the reciprocal of a number, top of page 340, is the number that must be multiplied by it to get 1. So the reciprocal of x is 1 over x, and because x times 1 over x is equal to 1, the reciprocal of x over y is y over x. Okay? The idea of the reciprocal of a number is useful because it gives us another way to look at division. Dividing by a fraction, or any number, is equivalent to multiplying by its reciprocal. Now here's some examples, and we'll just look at them. We're not going to go over them on the board, but we have divide 2/3 by 4 over 9. So we'll write them as they're written, and I mean we can write them the first method with the division bar. Okay, we can do it this really hard method here if you want. I'm not saying there's anything wrong with it, but all you have to do is take 2/3, write the quotient sign, dividing it by 4/9, and then now turn around the 4 and the 9 and say 2/3 times 9/4. Okay, and again they start breaking out the factors, and you end up with 2 times 3 times 3 and 3 times 2 times 2, and they eliminated the 2's and 3's, and it was 3/2. You could have simply multiplied them and probably reduced it another method, but again we can see that dividing by a fraction is the same as multiplying by its reciprocal. So let's say divide 5/8 by 2. Now 2 is a whole number, but we know that really you can express 2 as 2 over 1. So when we turn it around, we'll say 5/8 times 1/2. And again, we get 5/16. Now we have another. Divide x over 6 by x over x plus 1. Well, we have x over x plus 6 with the quotient sign divided by, and then x over x plus 1. What do? We flip the x plus 1 to the top, put the x below, and multiply. And again, now we end up with a little opportunity here of, before we even multiplied, of eliminating these two x's here, and we ended up with x plus 1 over 6. So you see it's not that hard. Well, maybe it does get a little harder because you're going to need to find the opportunities to factor, okay? And here in example number 4 we do present that opportunity. We have x squared minus y squared, and you divide that by x minus y over 9. So again, we write it with the quotient, And then we flip it the other way, and we put the 9 on the top and the x minus y on the bottom. Okay. Now we end up with 9 times the binomial x squared minus y squared over x minus y. Now, you got to stop for a minute and think. We have the difference of two squares, okay? Factoring. How do we express the difference of two squares? Well, as we can see here, we take x and y and we represent them as x plus y times x minus y. All right? And in doing so, we gave ourselves the opportunity to eliminate the x minus y factor, and we ended up with simply 9x plus 9y. So you look at this really complicated divide x squared minus y squared by this x minus y over 9, and that looks really complicated, but look, it's really something that simple. It's just 9x plus 9y, and we took a simple shortcut to get there. So again, I took a really shortcut because I don't want you to get confused with a lot of that hard math that might have just completely shut you down. It really is simple as just taking the reciprocal, okay? And that's the end of lesson number 7.